Hi everybody, today we're going to be talking about chapter 7.3, trig substitution. And I'm going to show you a few things that you want to look for when you're going to be using trig substitution. So the three things that we're going to look for inside of the integral is going to be the square root of a number squared minus x squared, or any variable squared that we're trying to take the integral of, a number squared plus x squared, and then the square root of x squared minus a number squared. And we're going to look at all three cases and what we're going to do to solve them when we have the integral with respects to x. Okay, for the first case, a squared minus x squared. We're going to substitute x for a sine theta. And that's going to give us a dx of a cosine theta, d theta. Because when we take the derivative of sine theta, we're going to get cosine theta. And then a squared minus x squared is going to equal a cosine theta. So if we look at an example, the integral from 0 to 1 of x cubed multiplied by the square root of 1 minus x squared dx. We can see that we have a number squared, which is just 1 squared by itself, minus x squared. With respects to x, we're going to use this one, the one I just described. So if we let x equal a, which is just 1 sine theta, then dx, if we take the derivative of that, is going to just equal 1 also cosine theta d theta. So now we're going to substitute everything in. So the integral from 0 to 1 of x, which is sine cubed theta, times the square root of 1 minus sine squared theta. Now, as I said earlier, the square root of a squared minus x squared is going to equal a cosine theta. And we can see that here because 1 minus sine squared theta is really the square root of cosine squared theta, which is going to give us a cosine theta, or 1 cosine theta. So what we're left with is the integral from 0 to 1 of sine cubed theta times cosine theta.